Coming to elastic collision in one dimension. In one dimension. Okay, one dimension. Elastic collision in one dimension. So one dimension means it is a straight line. So okay, the particles or objects which are moves in a straight line. Say either it is x or either it is y axis. Okay, so collision means we know that collision is an isolated event in which two or more bodies are colliding each other which exert strong force. So we know that collisions are two types. What are they? Elastic and inelastic. So elastic collision means in which type of collision momentum and kinetic energy can conserve. Okay, that type of collision we can say elastic collision. Examples of elastic collision is the collisions between subatomic particles. Subatomic particles means alpha particle is colliding with nuclei, gold nuclei like that, or alpha particle is colliding with uranium nuclei. So okay, so which are used in nuclear reaction, we know very well. So coming to inelastic collision. Inelastic. Okay, so elastic, inelastic. Inelastic means the collision in which momentum can be conserved but kinetic energy not conserved. Momentum conserved but kinetic energy will not conserve. Such type of collisions we can say inelastic collision. Examples: the collision between two vehicles, okay, in which kinetic energy cannot be conserved. Kinetic energy which conserves in the form of heat and light energy. My dear children. So this derivation, elastic collision in one dimension, which is very important one. Okay, so which is very important one. Okay, so here in this situation, consider two colliding bodies, they are having different velocities. After collision we can observe final velocities. So in this we can define elastic collision. After that we have to find final velocities of the colliding bodies. Yes. Okay, so understand, this is about the introduction of elastic collision in one dimension. Okay, so consider two bodies m1, m2. Okay, so their initial velocities u1 and u2. Okay, they are moving with different velocities. Here what happened, u1 is greater than, the condition is u1 is greater than u2, means if this condition we can get the collision. So if this condition not obey means no collision take place. Understand? So this is the condition. The condition is u1 is greater than u2. Okay, so collision take place m1, m2. After collision, this bodies moves with different velocities. Understand? Okay, so here we have to find final velocities of the body after the collision. Okay, so what is elastic collision? Means in which momentum can be conserved and kinetic energy can be conserved. Okay, understand? So first one, according to conservation of linear momentum and momentum both are same. Okay, understand? Linear momentum. So we know that according to conservation of linear momentum, what that condition, momentum total momentum before the collision which is equal to the total momentum the total momentum after the collision. The total momentum after the collision. Understand, my children? Okay, according to this case, we have to write m1 u1 plus m2 u2, because m1 u1 is the momentum of the first body before the collision, m2 u2 is the momentum of the second body before the collision, which is equal to m1 v1, momentum of the first body after the collision. Okay, m2 v2, momentum of the second body after the collision. Understand? So this is the statement. Okay, so all m1s we can send left side, all m2s we can send right side. m1 u1, okay, minus m1 v1, okay, that is equal to m2 v2 minus m2 u2. Okay, so m1 is common, u1 minus v1 is equal to m2 is common, v2 minus u2. Okay, so this is equation 1. That is equation 1, my children. All of you please copy from the board. Okay, so this is lengthy derivation. Okay, note it. Okay, understand? Somewhat lengthy this derivation. This is equation 1. Okay, what is equation 1? m1 u1 minus v1, that is equal to m2 v2 minus u2. This is equation 1. Okay, understand? Next, according to conservation of kinetic energy. Conservation of kinetic energy. Conservation of kinetic energy means what? What, my children? Yes, the total kinetic energy before the collision, which is equal to the total momentum, the total kinetic energy after the collision. Understand, my children? Okay, so now what is the total kinetic energy of the before the collision? So we know that kinetic energy is equal to 1 by 2 mv square. Like that, this is the formula based on this. Kinetic energy of the first body 1 by 2 m1 u1 square. Kinetic energy of the second body 1 by 2 m2 u2 square. Okay, that is equal to after the collision 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. Understand? Okay, so here 1 by 2 gets cancelled. Okay, so we have to write all ones left side, all twos right side. m1 u1 square minus m1 v1 square, that is equal to m2 v2 square minus m2 u2 square. Okay, so here m1 is common, m1 u1 square minus v1 square, m2 v2 square minus u2 square. Okay, understand? So this is equation 2. Okay, understand this here u1 square minus v1 square, we have to write like that: a square minus b square is equal to a plus b, a minus b, like that. Here u1 square minus v1 square, we can write u1 plus v1 into u1 minus v1, like that. v2 square minus u2 square, we can write v2 plus u2, v2 minus u2, we have to write like that. Okay, understand? So by cancellation. Okay, understand? Equation 2, remember equation 2. My children, remember equation 2. Okay, what is equation 2? m1 u1 square minus v1 square, that is equal to m2 v2 square minus u2 square, that is equation 2. Okay, so next equation 2 by equation 1. Equation 2 by equation 1. Understand? So what is equation 2? m1 u1 square minus v1 square divided by m1 u1 minus v1, that is equal to m2 v2 square minus u2 square divided by m2 v2 minus u2. Okay, so according to this we have to write m1 m1 m2 m2 gets cancelled. We have to write this one based on this equation u1 plus v1 u1 minus v1 divided by u1 minus v1, that is equal to v2. Instead of a square minus b square we have to write a plus b, a minus b. v2 plus u2 v2 minus u2 divided by v2 minus u2. Okay, see here u1 minus v1 u1 minus v1, v2 by v2 minus u2 by v2 minus u2 gets cancelled. So we have to write u1 plus v1 is equal to v2 plus u2. Okay, all initial velocities, all final velocities we can send opposite side. u1 minus u2, that is equal to v2 minus v1. Okay, understand? This is equation 3. Equation 3. Understand? Equation 3, my dear children. Understand? Okay, so according to this, so we have to write the relative velocity, velocity before the collision is equal to relative velocity after the collision. Understand, my children? Relative velocity before the collision, which is equal to relative velocity after the collision. Understand? Relative velocity before the collision and relative velocity after the collision. Understand? Understand, my children? Yes, we can say what, Nana? Equation 3, u1 minus u2, that is equal to v2 minus v1. Okay, this is equation 3. This is equation 3. Understand? So that we can say relative velocity before the collision is equal to relative velocity after the collision. Relative velocity before is equal to relative velocity after the collision. Understand? So this completed. So according to equation u1 minus u2, that is equal to v2 minus v1. Okay, understand? So this is the equation 3. Understand? According to this after collision, the relative velocity before the collision is equal to the relative velocity after the collision. Understand? So then we have to find the velocities of the bodies after the collision. Okay. velocities of the bodies after the collision, of the bodies after the collision. Understand how we can find the final velocities? Means say it is v1 and v2. v1 v2 value we have to find. v1 v2 values we have to find. Okay, my children? Yes. Okay, how we can find? We will find from the derivation. Okay. So once again I recall previous equation. So according to conservation of linear momentum, we can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Understand? From this equation, this is according to conservation of linear momentum. So according to third equation, what nana? Relative velocity before the collision is equal to relative velocity after the collision. What is equation 3? Equation 3, yes, u1 minus u2 is equal to v2 minus v1. Okay, understand? So from this is equation 3. From this we can separate v2 value we have to find. Okay, v2 value, from this v2 we can separate. What we can get? u1 minus u2 plus v1. Okay, understand? From this v2 is equal to u1 minus u2 plus v1. Say it is equation 4. Okay, so equation 4 we can substitute this equation. Okay, understand? Say it is this equation will give fifth. Okay, or first equation. Okay, fifth equation or first equation. Understand? So from these two equations, we have to substitute this value in this equation. We can get the final velocity v1. Okay, see here v2, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 u1 minus u2 plus v1. Okay, understand? Rearrange this. From this we have to find v1. Okay, see m1 u1 plus m2 u2 is equal to m1 v1 plus m2 u1 minus m2 u2 plus m2 v1. All v1s we can separate left side or right side. We can separate v1 value. Here v1 is there. m2 u1 minus m2 u2 we can send this side. Okay, m1 u1 plus m2 u2. Okay, m2 u1 minus m2 u1. This we can send left side. So minus value we can send this side. We can get plus m2 u2. That is equal to m1 v1 plus m2 v1. m1 v1 plus m2 v1. Okay, understand? This we can separate. v1 is common. m1 plus m2 into v1. Okay, what is v1, my children? What is v1? Yes, the final velocity of the first body. Rearrange this, my children. Okay, m1 u1 minus m2 u1. Here u1 is common. m1 minus m2 u1. Next, plus m2 u2 plus m2 u2. 2 m2 u2. Okay, understand? 2 m2 u2 is equal to m1 plus m2 into v1. Okay, we have to find v1. This term we can send left side. Okay, Understand? So we can write m1 minus m2 u1 plus 2m2 u2 divided by m1 plus m2, that is equal to v1. Okay, so this is equation 6. Understand? Okay, remember this equation. Okay, understand? 2m2 u2. We can rearrange this equation. Okay, be careful, my dear children. Okay. Okay, so rearrange 60 equation. 60 equation we can rearrange it. m1 v1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Okay, so this is the equation 6. Okay, understand my children? Equation 6. Okay, so what is v1? V1 is what, ma? Yes, final velocity of the first body after collision. The particles or the objects moving with the different velocities. Okay, two object is there. First body final velocity. Next, second body final velocity we have to find. Okay, understand? So coming to v2, how we can find v2? Okay, next v2 how we can find? Okay, from the according to conservation of linear momentum, we can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, understand? Next, we know that relative velocity before the collision is equal to relative velocity after the collision. That is equation 3. Okay, so from the previous derivation. Okay, I think equation 2, I think you can see the previous video. Okay, I think equation 3. Okay, from this 2 means v1 we can send rearrange this, we can get v1 is equal to what? v2 minus u1 plus u2. Okay, understand? Rearrange this one simply. Okay, v1 we can send this side positive, u1 negative, minus u2 means plus u2. Okay, so this equation 7. Okay, from 7 and conservation of linear momentum. From these two equations, we have to write m1 u1 plus m2 u2, that is equal to m1. What is v1? Yes, v2 minus u1 plus u2 plus m2 v2. From m2 v2, rearrange this m1 u1 plus m2 u2. Yes, m1 v2 minus m1 u1 plus m1 u2 plus m2 v2. Okay, understand? So here we can take only v2 values, m1 v2 plus m2 v2. Okay, these are all sent left side. m1 u1 here m1 u1. Okay, be careful, my children. m1 u1, this we can get positive, m1 u1 plus m1 u1 2 m1 u1 plus next m2 u2 Next m1 u2, m1 u2. Okay, so m1 u2 minus m1 u2. Okay, m2 minus m1 u2. Okay, so after that we can take like this. Be careful. So this m1 u2 can send this side, negative it will come. Okay, rearrange this, we can get this one. So here m1 plus m2, m1 v2 plus m2 v2, v2 is common, m1 plus m2 into v2. Okay, so we have to find v2, we have to find v2. Okay, same equation, 2 m1 u1 plus m2 minus m1 into u2. Okay, understand? Okay, yes, it is visible. Rearrange this, v2 is equal to we can send m1 plus m2 here, multiplication here, we can get division. 2 m1 u1 by m1 plus m2, yes, it's visible. Okay, plus m2 minus m1 u1 u2 divided by m1 plus m2, m1 plus m2. Okay, understand my children? This is equation 8. Okay, my children, this is equation 8. Okay, so I think in video not visible, so once again I will write this equation. v2 is equal to 2 m1 by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. This is the equation. Okay, understand my children? This is the derivation. These are the final velocities of the bodies after the collision. Okay, be careful. So once again you can go through complete derivation. Okay, understand? Yes. Okay, so briefly I will explain this total content in a single shot. Be careful. Okay, so we know that collision, the strong interaction between the two bodies or colliding bodies which exert some force and some momentum. Okay, see here, first equation, according to conservation of linear momentum, we can write the equation m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, according to conservation of kinetic energy, we can write 1 by 2 m1 u1 square plus 1 by 2 m2 u2 square plus 1 by 2 is equal to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 whole square. Okay, say it is equation 1, it is equation 2. Okay, from equation 1 and 2, rearrange this, we can get that equation. Yes, what we can get that equation means okay, so this is equation 2. After simplification we can get that third equation by rearranging u1 minus u2 is equal to v2 minus v1. Okay, so this is relative velocity before the collision is equal to relative velocity after the collision. Understand? So here u1 u2 known values and v1 v2 unknown values. Okay, how we can find means by using these two equations. Rearranging, we can get v1 is equal to okay, So from the derivation, V1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 by m1 plus m2 u2. Next, this is equation 3, equation 4. V2 is equal to 2m1 divided by m1 plus m2 u1 plus m2 minus m1 divided by m1 plus m2 u2. This is equation 5. Understand? So this is entire derivation. My children. Okay, according to conservation of linear momentum, conservation of kinetic energy, 1 by 2 gets cancelled. So rearrange this. So from equation 1 and 2 you can get this equation, relative velocity before the collision equal to relative velocity after the collision. Okay, from this two equation we can get final velocities. Okay, my children.